The following video is an introduction to one of the most important topics in probability theory, the so-called normal distribution. Imagine that we have from some data a histogram like this. So they have several properties, but one of them is that it's symmetric. Symmetric in this way. There are shorter rectangles to the left, and when you move to the center, the rectangles becomes taller and taller until you get to the center of the distribution and move to the right. These rectangles becomes shorter and shorter again. If that is the case, you are speaking about the normal distribution. So if you want to really recognize that this is a normal distribution, you should take more data from the population. And if you do that, so obviously the intervals will be smaller, and now you are going to have more rectangles, and these rectangles will be like this. So the symmetry continues. And the symmetry continues in the same way. So close to the center, we have the tallest rectangles. And if you take more data, and you make these rectangles narrower, so for sure that you are going to have something like this. And if you make the frequency polygon, so that means if you join the middle of the roof of each of the rectangles, what you are going to obtain will be a curve that is bell-shaped. This defines the main feature of the normal distribution. This is what is called the empirical rule. And the empirical rule says that most of the data are close to the mean. If sigma is the standard deviation, we say that 68% of the data falls within one standard deviation from the mean. So that means that around 68% of the data are between mu minus sigma and mu plus sigma. And 95% of the data, or around 95% of the data, falls within two standard deviations. So it means that around 95% of the data are between mu minus 2 sigma and mu plus 2 sigma. And finally, almost 100%, almost all the data are between mu minus 3 sigma and mu plus 3 sigma. So most of the data falls within 3 standard deviation. So remember, all these rectangles here are in percent. If you add together all the height of these rectangles, we say that we obtain 100%. We can think that the whole area below the curve is 100%. So to know this percentage here, help me to know what percentages are in some special part of the distribution. So, and here at the top, as you observe, there are not 68, 95, and 100%. No, there are more exact rules. Yeah? So actually we know more. We know that it's not only around 68%, it's exactly, or at least rounded to 2 decimal places, 68.26. Written in this way, I will say that we have the empirical rule more precise. So we know that, and knowing that help me to solve problem. For example, imagine that we have a well-known store that the purchase of the customer follows the normal distribution. And we have this situation. The average purchase for a customer is $45. So we know the average, we know the mean. And we know also that the standard deviation has been so far $5. So we have made the experiment, we have observed this, We know that this follows the normal distribution, and we know the mean and the standard deviation. I would like to answer this question. What is the probability that the next customer purchase is more than $40? So let's type the information here. First, the mean is 45. Yes, mean is 45, and the standard deviation is 5. So we have the mean and the standard deviation. So we can change this situation. For my distribution, this mean here is 45. So let's type, instead for using my distribution, let's type my 45. So the mean is 45. And now my standard deviation is 5. The standard deviation is 5, so 45 plus 5, this number here will be 50. And 45 minus 5, the number here will be 40. So between 40 and 50, there are 68.26% of the data. So because sigma is 5, then 2 sigma will be 10. So 45 plus 10 will be 55. The number here will be 55. The number here will be 35. Let's type these numbers. 35 and 55. Now, in my problem, I know that 95.44% of the data falls within 35 and 55. And finally, 3 standard deviation will be 3 times 5 will be 15. 45 plus 15 will be 60, the number here. And here will be 45 minus 15 will be 30 here. Let's type these numbers. Okay, now let's focus in the question. What is the probability that the next customer purchases more than $40? So we are not thinking in this area that is between 40 and 50. If say more than 40, if more than 40 refers to all this area. So the probability or the percent of customer that purchase more than $40 is adding together all the rectangles in the histogram that are after 40, so at the right of 40. So actually, so we are interested only in this part of the graph. So I just put these two colors. So this shaded area here give me the proportion of customers that purchase more than 40, and obviously this is the probability that the customer purchase more than $40. So if we want to know that, we can solve it now with the information we have. We have some areas only, but I notice here that if I want to compute the whole area, so the whole proportion of data that are more than 40, what I need to do is add together the area, the green area here with the gray area here. So will be the probability that a customer purchase more than 40 will be, or the probability that the random variable is more than 40 will be the area in green, so this green area, plus the gray area that is here. So, and I think we can compute it because I'm interested in this part, so I have erased the other percentage that I have here, but I noticed that the whole area is 100%. So, and I know that the gray area is half of the whole area. So I get this gray area is actually 50% or 0.50, for example. And this green area is also easy to compute because I know that all this part here is 68.26. We know that 68.26% of the data falls within one standard deviation. That means between 40 and 50. So that means that all this area here is 68.26%. Obviously, I'm not interested in all this area between 40 and 50. I'm just interested in half of this area. So you notice that this is completely symmetric. So this part here is exactly to this part, to this green part here between 45 and 50. Yeah? The green part is exactly the same to the part between 45 and 60. So this green area is only half of this 68.26%. So the answer will be the area green area will be 0.68.26 over 2 plus the gray area that for sure will be 0.5 because it's half of the whole bell. Yeah, so 0.5. So that means that the answer is 0.8413. So I just divide this number divided by 2 and add 0.50. And that means that the whole probability of the probability is 0.8413. That the probability that the customer purchase more than $40. This is also the answer for the question, what percent of customer purchase more than $40? And this is 84.13%. So you can answer in this way or in this way. So you notice here that to compute the probability is just to compute the area under the curve, yeah, and the area in percent will give you the probability. So in a continuous distribution, the probability that the variable falls between two given values is the area under the distribution curve and the two values. So it means if I have the information for all the areas or more areas, I will have the probability or the possibility to answer more questions. So far, with the areas that I know, 68, 95, and 100%, I can answer some question. I already did one, yeah? But I would like to know more areas, not only between 45 and 50. I would like to know what happened between 45 and 46, between 45 and 46, 7, etc. So the good news is that we have this information, and we have this information, and we're gonna show you some. So if we study this distribution, we are going to learn more. Okay, so let's see what is the normal experiment. I'm going to call the normal experiment any random experiment that produces a random variable that follows the normal distribution. It has several features. For example, it's a continuous distribution. So we are analyzing a continuous variable. Second, when many values are considered, the relative frequency polygon of the variable tends to be the normal curve that I show you. Yeah, it's a bell-shaped curve that follows the empirical rules. So there is a mathematics way to write this, and the mathematics function that define the normal experiment, it will be like this. The f of x equal 1 over sigma times 2 times the square root of 2 pi. So if you see this is maybe one of the functions that combine these two important constants in mathematics, pi and e. Eh? The base of the natural logarithm and the number pi. Yeah? Because they say times e to the power, and this is a fraction in the power, minus x minus mu square divided by 2 sigma square. And this is the function that defines a normal distribution that has a standard deviation sigma and mean mu. So obviously, if I made the graph of this function, it will be like this. The mu will be here in the middle and will satisfy everything that I told you. Yeah? And the good news is that we have information of some areas under this curve. So I will tell you soon what are these. But what are other properties? For example, you see here is completely symmetric. So it's symmetric, and the symmetry is around the mean. So the mean is in the middle, and if you see the left side, after when you see the mean, it's exactly the same to the right side. It's unimodal, so there is only one mode. So remember, the mode is the data with the highest frequency. Yeah, so the mode will be here, it will be only one mode. There is only one point that is the highest one. And this mode is exactly the mean that I told you. And it's exactly the median, because it's 50% of the data are above of this mean, and 50% of the data are above. So the mean, the mode, and the median are the same. And this asymptotic to the horizontal axis means if the graph approach to the right, approach to the horizontal axis, approach to the x-axis. To the left also approach to the x-axis. So this means that it's asymptotic. So it approach to the x-axis without touching it. And finally, if we want to compute the probability, the thing that we need to do is just find between two values, the probability that the variable falls between two values. The probability is just the area under the curve and between the two values I'm looking for, A and B, for example. So, and I told you before that if I know all the areas, if I know, or I have the possibility of know all the areas, I will have the possibility of find the probability that the variable x falls in special regions, in whatever special region. So let's see, and this is the case. So we have this information. There is a table that is called the standard normal distribution table. It looks like this. So we have like a column that has in the title Z, and these are the values of the variable Z, and Z will be, we're gonna see, are the distance in a standard deviation from the number to the mean. So this Z is computed using a formula, and it's called the Z-score. And this, as I told you, measure how many standard deviations from the mean a value x is. If I give you a value that followed a normal distribution, and you know the standard deviation and the mean, I can find how distant is this value to the mean, and the distance in standard deviations. So this is the formula. The Z is the so-called the Z-score. The Z-score will be x minus the mean divided by sigma. So, for example, if you know a value that is, let's say, mu plus sigma, mu plus sigma is x, mu plus sigma minus mu is just sigma, sigma divided by sigma, the answer is 1. So the z value for x plus, the z value of x plus sigma is 1. Or what about the z value of mu? Will be when x equal mu. Mu minus mu, 0. So divided by sigma, 0. So mu has also a z value. Whatever value have a z value. Yeah. So, but if you want to know what distance is this value to the mean, the only that I need to do is just find the z-score. So get the value, subtract the mean, and divide by the standard deviation. That gives you then that you can find, for example, what happened, for example, is z equal 1. Is z equal 1, and so that means that the variable, that the value that has this z value is 1 standard deviation to the mean. Yeah. And what will be the distance, what will be the percent or the probability or the area, that is the same thing, probability proportion area will be now the same thing. And now there will be what is the probability that the value will be between 0, the mean, and this value that have this z-score is given here in the table. So this value will be here, is one distance, one standard deviation to the mean. The mean is here. One standard deviation to the mean will be has a z-score of 1. So we know this area. If we want to know this area, the only that we need to do is just look at the table, go to number 1. Number 1 is here, and beside this number 1, it will be the area. This green area here give me the area between 1 and 0. So this is the value mean whose z-score will be 0. Yeah. So this will be the area here, 0.3413. But also is the distance between, in a standard deviation, between this value and the mean. So this area here is the probability that the variable has a value between the mean and the value whose z-score is 1. Okay, if you want to see this bigger, what is this number? Okay, let's see here. So the area is 0.3413. So this area here is 0.3413. That is actually the half that we have before. Remember the 68.26? Yeah, from that, because include the other part in the negative part of the curve. So when z equal -1 at these sides, all the values that are within one standard deviation, remember, was 68.26. Now this is just the half, 30.3413. So this is the value of the area. This is the z-score. It will be in the first column. And that defines a new normal distribution. Will be a normal distribution whose mean will be 0, and the standard deviation will be 1. So it will be the number that is one standard deviation. So the standard deviation will be 1, and the mean will be 0. So this table actually defines another variable that is also normal, but the mean will be, for this variable, will be 0 and the standard deviation 1. This distribution is called the standard normal distribution. And obviously, people call this the standard normal distribution table. But now help me to solve whatever problem I have in probability. Yeah, I can use this, whatever problem that I have about the normal distribution. So for example, if I ask you what is the probability that the random variable is between this and this value, oh, for sure, I'm gonna solve this problem. Let's see how to use it. The steps are the following. First, find the number of standard deviation each of the values in the problem is below or above the mean. So you are going to find the z-score. This is another word, find the z-score. So using the formula z equal x minus mu divided by sigma. You know everything. What is everything here? Yeah, x is the value of the observation, mu is the mean, and sigma is the standard deviation. So if you want to know what is the z-score or whatever value, you put the value here and subtract the mean and divide it by the standard deviation. After that, the second step is find the area in the normal distribution, using the normal distribution table, using the table that I showed you before. This will be a way to do it by hand. Yeah? So use the normal distribution table to find all the areas of the number that you get the z-score in the previous step. So you get the z-scores, and after you get the z-scores for each of the values, so then you are going to compute, you are going to find the area in the table. Usually the table is like the one that I give you, that they compute the area between 0 and the corresponding z-score. And finally, at the third step, you are going to find the probability. And you are going to find the probability depending on the problem. So you have the areas, but maybe you need to add the areas, or sometimes you need to subtract the area or leave the areas as they are. So depending on the problem, and I'm going to show you why. Yeah? So it's a good idea to make a sketch. So you make a sketch of the normal curve and try to see what areas are the ones that are asking you in the question. Then you are going to know if you need to add or subtract. For example, if you have a graph like this, yeah, and the question was, what is the probability of x is greater than 40? Remember, this is 40, this was 45 the mean. So greater than 40 will be all this area. Greater than 40 are all the numbers that are at the right of 40. Yeah? If you want to know this probability, and you know that the table only gives you the area between the number and the mean, just give you this area, and you know the other area is 0.5, okay, you're going to need you're going to need to add together the two areas. So in this case, you need to add the area. But what happens if I ask you not this, the probability of x greater than 40? What happens if I ask you the probability of this area lower than 40? And lower than 40 is all the area that is at the left of 40. If I want to find this area, I go to the table, and the table gives me this area. Always the table gives me the area between the number and the mean. And and the means, yeah, and the number, and this area is for sure a number in the table, but it's not the answer of the question. The question was, what is the probability of x less than 40? So in this case, you are going to make a subtraction, yeah, because it will be all this 0.5 minus the area that the table gives you. So you see that problem, it was different. In the first problem, you add together the two numbers. In the second problem, you subtract the two numbers that you have. And maybe the question is, what is the probability that the variable be between 40 and 45? Okay, so in this case, you don't need to do anything if the area is exactly what the table gives you, because the table gives you exactly this area. So let's solve another question, yeah? And just how to use this information, this step, for solving one question, one easy question. This is an example. The average purchase for a customer is 45, and the standard deviation has been 5. But now, so this is the same information I already told you, but now the question is different. What is the probability that the next customer purchase is between 40 and 55? So the question in mathematical language will be like this. Yeah? What is the probability that the variable x will be more than 40 and less than 55? So that will be the way I write the question in math words. If this is the way, so I need to find this probability. The first step tells me that I need to find the z-score of each of these values. So this first step, find the z-score of each of the value. Okay, they are asking me this, what is this area? Eh? What is this area here between 40 and 55? This was the question. Yeah? But what I need to do, I need to find the z-score of each of these values. Let's find the z-score of 40 first. So z will be x minus mu divided by sigma. This is the formula. In this case, x is 40. Mu is giving in the information of the problem is 45 divided by sigma, that is also giving in the information the standard deviation is 5. So it will be 40 minus 45 divided by 5, and this gives me minus 1. find also the what is the value, this is the value for 55 for the other value. Yeah? So will be again the formula x minus mu divided by sigma, but now x equals 55, so 55 minus 45 divided by 5. And I do this and the answer is 2. So let's type here 2. So that means that I have transformed all of these values in a z value. So now the question that was initially this way, now the problem has been transformed in this problem. What is the probability that the z value, so that now the new variable, the standard normal distribution variable, sorry, the standard normal variable, be between -1 and 2. So these two problems are equivalent. Yeah? You find this is the same of finding this. But this one is easy to find it because there is a table of this normal distribution. Okay, so let's find what is the second step. The second step is find the area of related to -1 and the area related to 2. So let's see. So this is the question, the problems now. We have transformed each of the value in a z value. And now I'm going to use the standard distribution table. Yes, find the area of -1. So I open the standard deviation and there is no negative number here. But don't worry, this is a completely symmetric table. Yeah. So find the areas here are numbered like 1. I can find the area between 0 and 1, but this area will be the same between 0 and -1 at the other side. So even if this number is negative, you are going to see the numbers, the values z positive. Yeah? So will be 1 here. I think let's put this as a little bigger now. Yes, 0, you go till 1. The answer is 0.3413. This will be the area related to -1. Let's write it here. The area related to -1 is 0.3413. And now the area corresponding to number 2. And the area corresponding to number 2 go from z to number 2. Actually, the number at the top refers to the second decimal of the value z. In this case, because it's 2, we will have more decimal, so the second decimal is 0. So will be 2, I think it's 0.4772. Let's see this bigger here, sorry. It will be 0.4772 for the value 2. And this will be the area corresponding to 2. And now I have finished the second step. Find the area. What to do with this area to answer the problem? That's what I'm going to explain using step number 3. And the step number 3 is find areas. So we know that the area corresponding to -1 was 0.3413. And this area is actually this area. So the value between -1 and 0. Anytime you find an area in this table, the area is between the number and 0. So when I find this number, I know that this is this area here. And then the area of 2 corresponding to 2 will be between 0 and 2, yeah? All this area. So what I have is this area is 0.3413, and this area here is 0.4772. So when I make the sketch here, I immediately recognize that if I need to know what is the area between -1 and 2, what I need to do is add together all these two areas. So in this case, what I need to do is add together the two areas. So that means that the probability, the question probability that the variable x be between 40 and 55, that is the same that the variable z will be between -1 and 2, will be the area of the first area, that is 0.3413, plus the second area, 0.4772. And this gives me a value. Use your calculator, and the value is 0.8185. That concludes my introduction to the normal distribution. In upcoming videos, you are going to see other problems related to the normal distribution, and I will be defining other continuous probability distribution. Thank you.